For today's video, we are going to answer a ladder problem in relation with related rates. So let's say, for example, a 17-foot ladder is leaning against a building. The foot of the ladder is 8 feet from the base of the building and sliding away from the building at 3 feet per second. On letter A, how fast is the top of the ladder sliding down the wall of the building? On letter B, how fast is the area formed by the ladder changing at this instant? And on letter C, find the rate at which the angle between the ladder and the ground is changing at this instant. So let us illustrate the given. So let's say we have a building, and this will be our ladder, and this will be the base. And let us represent the ladder as Z, the base as X, and this will be Y. The measure of the ladder, that is Z, which is 17 feet. And the measure of X, that is 8 feet, that is the distance from the foot of the ladder to the base of the building. And then, we are looking for the value of Y. And since the ladder slides away from the building at 3 feet per second, that is dx over dt. And as the ladder slides to the right, it also slides down the wall. Therefore, x is increasing and y is decreasing. And we are expecting negative answer for dy over dt. That is what we are looking for question letter A. But let us find first the value of y using Pythagorean theorem. Let's have z square equals x square plus y square. Z will be 17 and then square. X will be 8 square plus y square. 17 square, that is 289. And then 8 square, that is 64 plus y square. Let us move this one on the other side. It will give us y square equals 289 minus 64. That is 225. And let us square both sides of the equation to find the value of y. So y will be the square root of 225, that is 15. And the unit, that is feet. This will be the value of y. And then, let us find dy over dt. Let us have z square equals x square plus y square. Let us differentiate both sides with respect to time. The derivative of z square, that is 0, because there is no change in the value of z, and the value of dz over dt, that is 0. If you multiply it to 2z, that is 0. Therefore, the derivative of z square, that is 0. And the derivative of x square, that is 2x dx over dt, and the derivative of y square, that is 2y dy over dt. Let us cancel 2. Let us move on the other side. It will give us negative x dy over dt. Then let us substitute the given. The value of x will be 8 feet. And then dy over dt, that is 3 feet per second. And then y, that is 15 dy over dt. Negative 8 multiplied by 3, that is negative 24 feet per second equals 15 dy over dt. Let us divide both sides by 15. The value of dy over dt, since negative 24 over 15 is divisible by 3, it will give us negative 8 over 5 feet per second. And this will be our answer for letter A. And on letter B, how fast is the area formed by the ladder changing at this instant? So let us have another sheet of paper in order for us to answer letter B. The formula for the area of the triangle, that is 1/2 base times height, this time will be x times y. And then let us differentiate both sides of the equation with respect to time. let us have the derivative of a with respect to time, that is dA over dt. Since we have a product of x and y, let us have u as 1/2 x, v as y, u prime, that is the derivative of 1/2 x with respect to time, that is 1/2 dx over dt. And v prime, that is the derivative of y, that is 1 dy over dt. And product rule, that is u prime times v plus u b prime. U prime, that is 1/2 dx over dt, and then v, that is y plus u, that is 1/2 x, and then v prime, that is dy over dt. So let us substitute the given. Let us have 1/2, and then dx over dt, that is 3 feet per second, and then y, that is 15 feet, plus 1/2, x will be 8 feet, and then dy over dt, that is the answer for letter A, that is negative 8 over 5 feet per second. So let us simplify. Let us move this one. 1 multiplied by 3 times 15, that is 45 feet square per second over 2. And then 1 multiplied by 8 times negative 8, that is negative 64 feet square per second over 2 times 5, that is 10. Let us find the LCM of 2 and 10. That is 10. 10 divided by 2, that is 5, times 45, that is 225 feet square per second. And then 10 divided by 10, that is 1 multiplied by negative 64, that is negative 64 feet square per second. So therefore, dA over dt, that is 225 minus 64, that is 161 feet square per second over 10. This will be our answer. On letter C, find the rate at which the angle between the ladder and the ground is changing at this instant. So let us have another sheet of paper to answer letter C. Let's write here. On letter C, the angle between the ladder and the ground will be here, that is theta, and we are going to use sine theta. Sine theta, that is opposite over hypotenuse. So let's say we have sine theta opposite to theta, which is y, and then hypotenuse, that is z. So let us write this one as sine theta equals 1 over z times y. And then let us differentiate both sides of the equation with respect to time. The derivative of sine, that is cosine theta. And let's have d theta over dt. And since z is a constant, let us have 1 over z, and the derivative of y, that is 1, then dy over dt. So let us substitute the given. Cosine, that is adjacent over hypotenuse. Adjacent side will be x, hypotenuse will be 17. So therefore, cosine will be 8 over 17. So this will be 8 over 17 d theta over dt equals 1 over z, that is 17, and then times 1 multiplied by dy over dt, that is negative 8 over 5 feet, or let's cancel this one first. So let us cancel 17 and let us cancel 8. It will give us d theta over dt, that is 1 times 1 over 5. So d theta over dt, that is negative 1 over 5, and the units is radian and per second. This will be our answer. So I hope you've learned from this lesson. Thank you so much for watching, and God bless us all.